We do get these from time to time where the city has to replace the water main line that comes from the house out to the street. Sometimes what happens with this is, they end up excavating out the yard. Sometimes they're able to send a pipe all the way out to the street without doing that. In this case, the water main had been compromised or the water main line into this house had been compromised. So they had to replace the section from the interior of the house all the way out to the street. And that had been done in the early fall. And what they did was they did a fine job, but they opened up this large hole in the interior of the foundation, about 8 inches in diameter, in order to get access in there to replace that line. And as part of the service that the city will do, that's about as far as they get. They replace the line and they put a little cap on the exterior. So I do have a visual that I can show. This is what the actual hole looks like when we got in there. And this is right from the customer's house here. The problem with this repair that they did was that they just poured some concrete on the exterior side of the hole that they made. So in many cases, that's just a cap. So as the freezing and thawing happens through the winter time, that little bit of concrete that they put out there, that cap does not actually hold tight. So what do we have to do in this case? It's a large void space. It's leaking, obviously, very, very badly in this case. We had a lot of rain. They had a few inches of water in that area because of the amount of water that came through. And it was a wide open gap in the foundation. We're not going to cut out that portion of the foundation and report, because it's still structurally sound. It's just really a matter of understanding how we can best waterproof it and cap both ends of it. So in this particular situation, what we wanted to do is we wanted to pack in a cementatious-based material, so a hydraulic cement material that went all the way out to the outside of the foundation. And what that was going to be used for is almost like a better version of the cap that they already had put on there. And then in between that portion of the exterior, there's 8 inches. So that 8-inch void space that is also 8 inches in diameter is wide open. And so you can't just pack hydraulic cement in there that much, because it will eventually crack and the water's just going to find its way through. So what we use is the closed cell polymer resin material. And the reason why we use this material is, one, because it expands and fills that entire void space around the entire diameter and all the way out to the soil. The other reason why we use it is because it actually will bind to the concrete, to the hydraulic cement, and to the materials that are being used in here. In this case, it was a PEX line that they ended up using, so it's plastic. With that material, you're going to have that binding capability, and it has a bit of flexibility to it, so that as the temperatures change with the freezing and thawing cycles, those materials, because you have masonry on one side, plastic on the other, you also have a copper in there as well, these materials are all going to expand and contract at different rates. So you need to have something in there that is both going to bind to it, as well as move with that, the flexing of the pipes and of the concrete. So the other part of this it's a very careful portion, is that the materials that we have to use, we have to carefully select. We can't just go and grab any material off the shelf, because the material has to be safe for that supply. If for some reason it was going to rot or hit the pipe, it's going to totally, make the situation even worse. And now they're going to have to replace the whole line again. So this material is both safe for the materials that we're going to be using inside the wall, as well as also waterproofing. Because if that water, that material gets into the pipe, well, not only is it replacing it, but it's also going to plug the entire pipe inside and out. So this material is safe. It expands gently. It doesn't have a high exothermic, which is a heating reaction. So it's not going to cause any sort of melting of plastic. It's a gentle expansion. So we put this material in there, and then we put a hydraulic or masonry, specialty masonry cap on the interior. So if you think of the way this would look like, on the bookends of the wall, you'll have a cap of concrete and hydraulic cement on the exterior out to the soil. You have the middle portion, which is this waterproofing material that is now binding to all of the materials that are inside there. And then you have a hard cap on the outside. So these three kind of pieces all work together in order to safely waterproof that environment from the inside out. So when we got there just a few days ago, there was water actively leaking in. This thing was, had a bucket underneath there as we're doing it. And a lot of materials that are out there, you have to be dry. In this case, the materials that we're going to be using is water reactive. So it actually enhances the ability for it to set quickly and really bind well. So we're able to get that done, get it capped off. In this case, because we're very confident, we can be able to give them a full warranty on this type of repair. And then these people don't have to stay up at night every time it rains. So it was a very thorough repair. They were able to get that situation resolved. This is what the end result actually looks like here. So you can see that yellow bits that are kind of pouring out a little bit. That is actually the waterproofing material that comes out. It's nice and cleaned up. It's able to hold back water, and they can continue on with their lives without having to worry about that repair causing issues in the middle of the night anymore.